Hi all, I'm Jaideep Bommidi and I'm here to present my final project on atoxic exposure and health risk assessment across the United States. To handle this topic, I have taken the dataset from the National Scale Atoxics Assessment, and it provides a packed information on chemical concentration, exposures, and health risks, and serves as a map to navigate into this issue. The audience which I'm considering here are the public health officials and epidemiologists so that they can take valuable insights and identify pollution hotspot, link these to the health risks, and create targeted strategies and policy changes. So let's dive deeper or dive into the geographical distribution of exposure, concentration and risk levels. So I have created a parameter here so that that parameter is plotted against the state parameter, and the first parameter which I have chosen is a concentration. So the concentration, as you can see, California and New York as the highest, followed by Texas, followed and Illinois and Virginia Islands, Wyoming, North Dakota and South Dakota has the least. So considering these states, I can understand that the concentrations are higher in this. So once the concentration are checked, if we check the exposure levels, the higher the concentration, higher the people are getting exposure to the atoxics. And as you can see, Illinois, Florida, Texas, New York, and California are the top five in ascending order, and Virginia Islands and Wyoming, North Dakota have the least, and followed in the other states also in the middle follow a similar pattern. So we now, since we have seen the concentration and exposure levels of these air toxins, now let us consider the risk level, health risk which are people are facing. And you can see that the health risk is directly proportional to concentration and exposure because New York, California, and Texas, Florida have the same pattern and they are proportional to the previous graphs. And Virgin Islands, Wyoming, North Dakota, and South Dakota is the least. So one might question that is it that the states are the only reason, or is it that the population based on it, or the area of the state is playing a role? So hence, to understand that parameter, I have tried to plot scatter plot against population size and average exposure level, concentration and risk level. Here you can see that it's a scatter plot, and these are not well labeled because it is in a very small space, a large number of states. But as you can see here on the top, there are number of states, and California is on the top with 400 million population and the higher level of exposure and risk factor, risk level as well. But Texas, though it has 250 million, but it's able to maintain low spot and maintain half of the value of the exposure and risk levels, and hence I suggest the health officials from the other states like New York and California can consider Texas as to how they are handling, though they are in spite of having higher number of population. Now one might consider that I want to look into this smaller states. So what I have done is I have created two parameters where I can set the maximum number of exposure levels. As you can see here, Wyoming, North Dakota, which are the states with the lower number of risk levels, are having a very least population. So from here I can understand that population is directly proportional to the exposure concentration the people are facing. I have also created another parameter so that we can remove the states which are not in the consideration and only consider the population high states, so that we can have a correlation between the values, and these two parameters helps us to have a better visualization. Now once we have seen the correlation between this, now let us see how chemicals and how the human systems are getting affected. And here you can see the first plot is respiratory, followed by whole body, thyroid, neural systems, liver, kidney, immunity. And the respiratory system is affected by digen and acetaldehyde, followed by neural systems and thyroid are affected by cyanide, and the immunity is affected by benzene. So this is considering all the states. For example, if I go to California, I can see here that only the respiratory systems are getting affected by these chemicals, and the health officials should consider how to implement strategies. But one might consider that why only considering the states with higher population or higher exposure levels, but also take states with the lower exposure level or something. So as you can see here, if I take Arkansas, It is clear that it has a population of 7.5 million, but still it has a respiratory issues because of the chemicals released, and the benzene is affecting immunity, which was not the case in California, as to mention. So from here it is clear that these three graphs as a whole gives us a very whole idea of how the chemicals and the exposure levels of different states and the populations are affecting the overall health and environmental conditions. So we have got uncovered some significant insights which can be used by the public health officials, and then we recommend to focus on interplay of these factors and stimulating research into the industries which emanate these toxins and diving deeper into the chemical health systems interactions. So with this, our goal remains to foster healthier environments and communities intact. Thank you very much.